Now let us move on to an example. The table 18.1 represents total physical product, average physical product and marginal physical product of a farmer. See, when input level is 1, total physical product is 15. And if an additional unit of input is added, that is when 2 inputs are used, total physical product is 38. 3 inputs are used, TPP becomes 66. And when 4 inputs are used, it becomes 96. When 5 inputs are used, the TPP increases to 120. When 6 inputs are used, it increases to 126. And when 7 inputs are used, it remains as 126. And when 8 variable input is used, TPP declines to 120. When 9th unit is used, it again declines to 90. And if 10 inputs are used, TPP declines to 50. So this is about TPP. Now, how can we find APP, average physical product? So average physical product is total physical product divided by input level. So when first input is used, TPP is 15. APP will be 15 by 1. Again, it is 15. Then, when second unit is used, what will be the APP? TPP by input level is APP. So, 38 by 2 is APP. So, average physical product becomes 19. And when 3 inputs are used, APP becomes 66 by 3, that is 22. Likewise, we can find average physical product. Then how can you find marginal physical product? So marginal physical product is change in total physical product by change in input level. That is delta TPP by delta X or delta input level, change in input level. So here, change in total physical product. 38 minus 15 by 2 minus 1 is marginal physical product, 23. Then, coming to the third point, third input level, MPP will be 66 minus 38 by 3 minus 2. Fourth input level, MPP will be 96 minus 66 by 4 minus 3, that is 30. So likewise, we can calculate marginal physical product. Now, these are the total physical product, average physical product and marginal physical product of a farmer. Now, let us calculate marginal value product and marginal input cost in order to find the optimum input level. So here we are assuming that labor wage is 30 per man day. That is, one charge of 1 man day is 30. And price per kg of output is 5 rupees. So 1 kg, if it is rice, 1 kg of rice, the price is 5 rupees. And wage of 1 labor, 1 man day is 30. Now, we have total physical product and total and marginal physical product. So that we have already calculated. Now we have to calculate total value product. So we know that total value product is TPP into price per unit of output. That is TPP into 5 rupees is TVP. So we can easily calculate total value product. So first unit total value product will be TPP into 5, that is 15 into 5, 75. Second unit total value product will be 38 into 5, 190. Third unit TVP will be 66 into 5, 330. Fourth unit TVP will be TPP into 5, that is 96 into 5, 480. And likewise, we can find total value product. Now we know that to find optimum input level, we have to calculate marginal value product. So from TVP, we can easily calculate marginal value product. So marginal value product will be 190. For second unit, marginal value product will be 190 minus 75 divided by 2 minus 1. For third unit, it will be 330 minus 190 by 3 minus 2. Or we can calculate marginal value product by multiplying MPP with 5. So MPP into 5. Price per kg of output will also give you marginal value product. So 23 into 5, 115. 28 into 5, 140. 30 into 5, 150. So likewise also you can calculate marginal value product. So either from TVP or MPP you can calculate MVP. So we can calculate MVP. Then we have to get MIC, marginal input cost. So we know that marginal input cost is the cost of one input, one variable input. We are only using one variable input here, that is labor. And per day, labor cost of is 30 rupees. So marginal input cost is 30. By adding one variable input, the cost incurred is rupees 30. So MIC will remain 30. Okay. So MIC is 30 for every unit. Marginal value product is different for different unit. So we know that optimum level of input is achieved when MVP equal to MIC. So here MVP equal to MIC at 6th unit. So when we are using 6 labor or variable input, MVP equals MIC. So MVP is also 30 and MIC also 30. So 6th unit is the optimum input level. So optimum input level is calculated when MVP is equal to MIC. At that particular point, input level is optimum. So in this example, input level is optimum at 6th unit. Now let us calculate optimum level of output. Here optimum level of output can be calculated, or we can find optimum level of output at the equality of MR and MC. So we have TPP and MPP. We have to calculate marginal revenue and marginal cost. So total revenue. From TPP we can calculate total revenue. So TPP into price per unit of output is total revenue. That is, we have assumed price per unit of output is 5 rupees. So TPP into 5 will give you total revenue. So total revenue of first, while using first input level is 75, that is 15 into 5. Second unit 38 into 5, 190. And by using third input level, we will get 66 into 5, 330. Likewise, we can calculate total revenue. From total revenue, we can calculate marginal revenue. Marginal revenue is total revenue, change in total revenue by change in total physical product. We can also say that it is the price per unit of output. We know that price per unit of output is 5 rupees. So 5 rupees is the marginal revenue and it remains same throughout the input level. Okay. Now let us calculate marginal cost. Marginal cost is the cost of one input by marginal physical product. So here cost of one input is 30 rupees. We know that cost of labor charge is 30 rupees. So marginal cost is 30 by marginal physical product. So we already have marginal physical product. So MC is equal to 30 by MPP. So MC is equal to change in input cost by marginal physical product. So we have only considered one single variable input, labor, and labor charges 30 for per man day. So change in input cost will be 30 rupees by marginal physical product that we have already calculated. So second input level, marginal cost will be 30 by MPP, 30 by 23, we will get 1.3. In third unit, our marginal cost will be 28, 30 by 28, we will get 1.07. Fourth unit will get 30 by 31. Fifth unit will get 30 by 24.8. And at the sixth point, marginal cost will be 30 by 6, that is 5. And seventh, that will be 30 by 0, 0. Eighth unit, 30 by minus 6, that is minus 5. And in the ninth unit, 30 by minus 30, minus 1. And 10th unit, marginal cost will be 30 by minus 40, minus 0.75. So we know that optimum level of output is determined at the point where MC equal to MR. So here MC equal to MR at the point at the output 126. So optimum output is 126. At that particular point, MC equal to MR. MC equal to 5 and MR equal to 5. So 126 is the optimum output level. And our optimum input level is 6. So the analysis reveals that whether it is the equality of MVP and MIC or MR and MC, the result as well as decision making is the same. That is, there is only one profit maximizing level of input and output for the given information. So in this particular table, we can see that profit maximizing or optimum level of output is 126 and the corresponding input level is 6. That is the optimum input level. So optimum input level is 6 and optimum output level is 126. So a farmer can either calculate optimum level of output or optimum level of input because both the result or the decision making will be same in both the case. So there is only one profit maximizing level of input and output for a given information. So a factor product relationship is very essential for making choosing optimum level of output and optimum level of input.